Well, hello, good morning to everyone. Thanks for waiting and for attending this webinar on the next generation Radar Altimetry Toolbox concept design workshop. My name is Roger Escolar from ISARSAT, and I will present to you the Sentinel-3 Toolbox project. This is a project under an ISA contract and is carried out by Demos Portugal, ISARSAT UK, and TU Delft, and it aims to update and improve the current BRAD toolbox and its website with the radar altimetry tutorial. So the idea of this webinar is to present what we are doing and mainly collect feedback from the users in order to meet as many requirements as possible. So, I will introduce you to the project, the main objectives, then we'll go through a practical example with the current BRAD, not the toolbox that we are building. Now it's just a concept design from which we want feedback from you and let us know what you think about it in order for us to adapt it to your needs. Then we'll present the new features, and in the end, we will send you a link to answer a survey, a quick survey that will take you 1 minute or two, not more, about, what's your expertise, what do you think you could need from a toolbox, and so on. So, this toolbox is an evolution of the existing one, the BRAD, the Basic Radar Altimetry Toolbox. But yeah, we have new data sets, we have or will include new functionalities and a new user interface. And this is also a main objective of this webinar, for you to tell us what you think about our idea, our concept design, so we can move forward and face something that is of your needs or your convenience. Apart from that, we will update the existing tutorial, which is online, and also create new tutorial material, because there has been few concepts that have arisen, and there will be the SAR tutorial. We'll go through that later. And another point that we have in mind, and it's one of our main objectives, is to have we want to reach all the users in the altimetry community, not just the expert ones. Once we go through the practical examples in BRAD, you will see that it's not easy. If you're not familiar with the environment, it's not easy to visualize things and export data, things like that. So a focus that we have is to reach all the community. And for that, we need feedback. So we need to know if we reach everyone's needs and requirements. So before we continue, I will show you a quick look of how the current toolbox works. It's the BRAD. And after that, we'll present the new features that we have included in an internal version, or the ones that we will include in the future. Well, so this is BRAD. This is the first screen that we see. And the first thing that we need to do is create a new workspace, which you can create here. I already created one, it's an empty one. And then you can see we have 4 tabs here on top. The first one is where we choose the data that we want to manage or select or, well, operate with them. Then we have the operations tab, where we do all the modifications, or we prepare the views, the plots that we want to visualize, or the data to export. Then after that, we have the views tab, where we plot internally already in BRAD, inside BRAD, without having to go to other applications. We can visualize the data that we've been operating with. And in the end, we have the logs tab, where we see all the progress that's been made. So I'll show you couple of examples of things we can do in Brad. So first thing is to create a new data set. We will name MVSAT GDR, which is geophysical data record. We're going to use the data that's already available in the website from the application that was, well, the toolbox that was built by CLS and Kines. So you can play with that also. So we select the data set, we see it here on the left. Once we select it, on the right we see all the fields that this product contains. We see all the parameters. We can sort them alphabetically by its name, the record. Now we're just sorted as they appear in the product in order. Once we have selected this data set, we go to the Operations tab. We have to create a new operation. We'll call it the same, just to match the data set. In this window here on the top left, we see the data set. If we had more data sets, we'd see a list, and we can choose whenever we build a new operation, we select the data set that we have here. Here in the bottom left, we see all the fields that are contained in the product, and our interest now is in the radar altimeter, so it's here. We have a lot of fields. We can sort them alphabetically for convenience, and on here in the center we see the data expressions, and on the right the expressions itself. So for now we're going to see the first thing is to visualize a field that is already included in the product. So we're going to see a 3D plot on the globe, and so the first thing is to set the x-axis and the y-axis. So we'll put the longitude and the latitude, and for the data we're going to visualize the ocean, the KU1 ocean range, which is the distance from the satellite to the observed area. Here on top we see the units. We can change them, and the Brad automatically does the conversion. We'll see, put it in meters, not in millimeters, which would be a huge number. Once we are happy with this, we can press execute. We saw the log for a while, and it just took 1 second to build the operation. This was quick. And after, when we finished, we're here again in this window, and if we want to plot this, we have to go to the Views tab. Otherwise, if we would like this to be in a netcdf file, for example, we could export it, or in an ASCII file, we could go to export, or export it also into a KML and see that this tracked in the Google Earth application. But we're going to the Views tab now, and we have to build a new display name, which we'll call MVSAT again. And here we have all the operations that are available. For now, we only have one, but in the second example, we'll see that we have both here. So we just drag this magnitude onto the right, and once we have it here, we can execute, and we'll see the plot. We have this window here. We can see the ocean range, well, the range here all over the track. On the right, we have editing tools like changing the color. We have a lot of color codes, but well, you can play with those and also create your own one. But we'll stay with the default one now, just for visualizing. So this is one thing, visualizing magnitude that it's already in the product, and this is quite straightforward. But for example, if we want to visualize sea level anomalies or sea surface height, we don't have it here in this product, and we have to build it from somewhere. The good thing, well, we're going to create another operation. We'll call it sea surface height. We choose the same data set. We'll choose also latitude and longitude. And for the data, we now don't want the range, we want sea surface height. So we'll insert an expression, an empty one, call it surface height again. And here we can see that it's empty, the expression. We could enter manually with our keyboard what we want to put inside, but instead we're going to put an insert formula that is already built in the Brad. See that we have a lot of formulas here, but for the same magnitude we have a lot of formulas. So you have to know what you're playing with. So sorry about that, I'm in the office. And well, once we press OK, we see the formula here. And if we're happy with it, we can press execute. We saw the logs again. We're going to the Views tab. We create a new display, call it SSH. And now here we select the SSH, which is the one that we want to visualize. Press execute and see again. Well, this is the same thing that we saw with the range, but now with another magnitude. The thing is, if we do it just in 2 dimensions, for example, let's create another one. This was over the globe, and we select same magnitude again, but only with the latitude. And here is data. We insert an expression, same formula as before, which is SSH and beside GDR. Okay. And now, let's visualize it and then we see what we get. Go to the Views tab again. You see here that we have 2D operations available, 3D operations available. Now we select this one and see what we get. We see this curve, and these high peaks are occasioned by Earth, by land echoes, and there's an option where we can delete these high peaks by selecting the data that we want to plot. So if we go back to operations, we have the same one, and well, let's call it SSH again, and we can duplicate this operation or create another magnitude. And well, let's make this one. And we have now the same operation as before, but now we're going to select the data that we want. So we have to know that there's a variable here that it's a flag. It's a flag for land characterization. So this, if we go over this variable, we see that for ocean it is 0, and then we establish that we set the condition that we want to meet, which is ocean, and now we'll see a different plot. We go to the Views tab, and the good thing is that we can include this second expression here. This copy, we can include it here and visualize it in the same plot as before. So once we execute, we see a plot with both plots. We can set the line a bit thicker so we see both lines. And here, when we can zoom and see that since we put the filter, we don't see this high peaks in the center. Instead, we get these values. It's just an interpolation. Well, it's just interpolation between the previous values, but at least we don't see the high peaks. So there's ways of filtering data inside Brad, but you have to know the product. And okay, we're finished with this first example. And well, once you have this condition set, you could include more data sets, for example, a full cycle, and then not having to repeat all the operations and setting these flags again. So we're going to create a new data set now, which is gridded data, mean sea level of mean sea level anomalies. We will add file, this mean sea level. Again, we click in the data set, we see the content of it. This was, it's not an official product, it's merged data. And we go to operations, we create a new one, which we'll call mean sea level anomaly. Now that we have two data sets, we see we have MVSAT, the previous one, and the current one. We see again these parameters here. And as before, we set the X, Y, and data. And here we can, yeah, it's in centimeters where we can keep that. And apart from visualizing it, here in the bottom right, we have some resolution and filters. And we see we have full coverage of longitude and latitude. We could edit that. And also the step that we want is a third of a degree. We could edit that. And also if we had gaps, because our gridded data is, for example, 1 degree, we could interpolate the data with these filters here. For the moment, we'll have it as default, so no editing right now. First, we'll execute this. It will take a few seconds. Yeah, so the operation has finished, and we go to the Views tab, create a new view, so it means the anomaly map, and we will select this 3D operation that we just created, which is this one, and execute it. And now we can see all over the globe the mean sea level anomalies from merged data, and we can zoom here. If we press central button of the mouse, we can flip the Earth, go back, do a lot of stuff. Also, we can edit the color here again, as before. We can edit the range, for example, said we only want to see positive magnitudes. Then in black, we see the magnitudes that are out of this range. But yeah, this is just fields that you can play with. And as we said before, well, we can go back and in the operations, we can cut this data because, for example, we may be only interested in the North Hemisphere. So we put minimum 0 latitude. We say, okay. And if we don't create a new operation, we overwrite the data that we had before. It's not a problem right now. So we will execute. A few seconds more, you can follow the log here, which tells you the progress of the operation. Also, you see this option here, this drop-down menu. This is for the cases where you have more than one file in your data set, and then you have to choose what you want to do with data that coincide at the same point. So you can say mean, or for example, the maximum number there, not doing the mean, or you can visualize the standard deviation all over the data files that you have in the data set. And we'll use the same display, and since we updated the data in the operation, we don't have to do anything here. So we just execute and see just the North Hemisphere, and you can do this. Well, so this is just a quick example of what Brad can do. And now we're going to show you what the new features of our toolbox are, and also the new design that we propose. So we can group these new features in 4 categories. We will be able to read new data sets. We'll have new functionalities, the new design that we already mentioned, and also the user support and interaction that we intend to do. So first, the data sets. Now we will be able to read NetCDF4 files. So Sentinel-3, JSON-3, and other satellite data, also reprocessed data from earlier missions will be available, and also other formats. And I would like to point out that Cryosat2 baseline C is available internally, but it will be available once the first version of the toolbox comes out. And also GeoSat data, either products, is river and lake products. And apart from that, we plan to integrate the RADS database. I don't know if you're familiar with that, but it's a huge altimetry database that a lot of users use as well. That's what I'm aware of. And we plan to include it in our toolbox, which is quite good, I think. And for new functionalities, compatibility, and a main objective is the reach as many users as possible. So we have a new computation approach, and as you saw, it's not straightforward to produce some plots and visualize some quantities that are not inside the product itself. So for beginners, we plan to have, we'll see it later with the user interface, but we plan to provide a set of parameters or fields or magnitudes, and with this default list, they will be able to see sea level anomalies or wind speed if it's not there, or sea surface height, without having to edit the data or introducing formulas and all this stuff that it's not easy if you're just beginning with the toolbox. And apart from that, for the expert users, now it's only available to upload formulas and algorithms in C code, which is, if you're not a programmer, it's not that easy. So we will include a Python API. So we think it's more user-friendly, and more users will be able to upload or use their own formulas and algorithms. Apart from that, now if you try to export data to KML or KMZ files, what the Brad does, it's only to plots an image but with no information. So what we do here is introduce more information about the cycle, the path, and all the useful information that we think that we could have there. Also, we are planning the port into 64-bit systems, and we're going to run analysis in order to import the toolbox into the GPod, which is the online platform from ESA. And finally, the new design. It's not easy to use Brad, and you have to go through 4 different tabs, go backwards, and it's not easy. It's not straightforward to follow. So what we want to do is create a more visual interface with only 3 easy steps, which are data selection, data management, and then export and view results. We're going to show you the concept design. It's not final, so we would like to know what you think about it and get some ideas from you or recommendations. So don't hesitate to do that. So here is our main screen, and we see that in the top we have 2 drop-down menus with a few options. We will go through them just before this slide, after this slide, sorry. On the bottom left, we have the configuration tools, the visualization and plotting tools, a quick link for saving the data set we've been playing with, and also the one-click button that I'll explain later what this is about. And on the bottom right, we have the help, also information and links to useful useful web pages from ISA or product formats or a lot of things. Then the information about the version of the toolbox that you were using, and then the exit button. So now we're going to see what we have in the data selection menu. We see we have 4 options, which are source, area, time, and mission. And for the source, we have 2 options. We have the RAT synchronization, as we already mentioned. So there's no need of downloading a lot of files in your computer if you already have them online. And if, well, you have your own products and you want to check them or visualize the things that you have produced or the ones that you already downloaded previously, you can choose the local folder and just browse in your system. Then once we have the data set, in fact, we can choose areas that we are especially interested in, not just the whole track or the whole data set. So we have a few options for selecting the data with box or free polygon, like you can do in Google Earth, and then you can import it from there. Or also we will have a default list of interest areas, and you'll be able to select them that list, like for example Antarctica or North Atlantic, South Pacific. Also, if you're really interested in an area and you think that it would be useful for other users to have it already as a preset, don't hesitate to tell us and we will include it. And after that, we think that it's important to have the option of having absolute dates, because we may be interested in one day, for example, but we also may be interested in having just 3 cycles from this day. And then that's why we added the relative dates and cycles, so we are more flexible when selecting the data. And finally, in the mission, we have options here. We will have more options as well. Satellites are working already and we update our libraries, but we have the satellites here with the type of products that we want. We can also have other levels of products. And a good thing that we have this visual interface is that once we select the missions, we can see the tracks here on the Earth and see if they overlap or not, and then maybe we don't need all the data that we have. So this is good that we don't have to wait until we do all the operations to visualize what we are selecting. Then once we have selected our data, we can manage it, and we have 3 levels of knowledge, or levels of time that we have to spend, maybe, or in seeing the data. So the first one is the quick look. It's the one for, well, quick looks, but also for starters in the app, so they don't have to select data over land or ocean. That will be already pre-selected. So you will be just clicking here and seeing the fields in the product or the magnitudes that have been created. And then for the advanced users and expert users, we're still working on the layout, because we have a few options of libraries and we still have to decide which ones we will choose for the project. But for the advanced users, this advanced user is the one that knows the product he's working with, and they introduce their own formulas, they introduce their own selection criteria, and the expert user is the one that does all that, but also includes new algorithms and, well, plays a lot or takes the toolbox to its maximum performance. For those, we would like to have also feedback, because depending on the needs of the users, we will choose one library or another. And in the end, we have this one-click button, which is this one here on the bottom left. This is really useful for those users who use toolboxes to visualize or to monitor data over the last month, for example, and it's always the same. And the only thing that you can do right now is select the data and store the polygon, the area that you have to select it. But saying the last month, that it's not possible right now. You have to set the dates all the time, and also always do the same operation. You cannot store the same operation. It can be quite quick if you're doing always the same. But here, in just one click, you can store all the tasks that you do every time that you use the toolbox. So we think this is a very useful feature for a toolbox. And apart from the toolbox, there's the website, the Altimetry portal, which will be soon available. And this is also a very important part of the project, because it supports the toolbox and it works with it. In this portal, the users will find the toolbox itself. They can download it from there. Also, the user manual, have access to data. And I want to emphasize this, that the users will be able to download the open source code of the tool. We want the users to play with it and then propose modifications or propose new contributions, which we will manage through the help desk, because we will have a repository where we will keep the versions of algorithms. We will provide feedback to the users. So this is a good feature for working for the community to work together and share our knowledge. And in the end, we will also have video tutorials that will come also both internally and externally, which means that all the users from the community will be able to upload the tutorials, and, well, of course, going through the help desk and through ESA, but we will have these tutorials both in the toolbox and also in the website. And for us, yeah, the Altimetry portal would look like this. This is a preliminary layout, so we also want feedback on this. We can access the sections on top of the page or on the bottom where we have these quick links. So you see we have the toolbox section where you'll find the main page of the toolbox for download, user manuals and documents about it. Also the link to the code where you can download it and propose all your modifications. We will have data access, as we mentioned, in this quick link. Then there's this webs and documents section, which is quite similar to the one that is already in the Brad tutorial, in the one that is linked to Brad. And it's a section where all the main reference documents from ESA and websites from Altimetry missions are, and it will be more or less the same. And on the bottom, we find the tutorial and also the SAR tutorial. The tutorial will be an update of the current one, because new concepts have arisen. And for the SAR tutorial, this will be completely new, because now we will cover CryoSat and Sentinel-3. And in the end, we find use cases, which will be practical examples and indications of how to proceed or how to use altimetry data. And finally, the contact section, where you will be able to contact the project, the consortium, and, well, get your answers, your questions answered, and or get help from the people inside the project. And this is all. On our side, we have this quick survey that we will circulate through email. You will receive it soon, and would be of help for you to answer it and to let us know what you think about this idea that we have, this project that we're building. So thank you very much. Also, you can ask questions through the questions and answers section in the Zoom, which I cannot see if you have been doing that, but we will answer all the questions that you may have.